Yes, good evening, everybody. Just to start with, there are a few of us here, so I was wondering if it was possible to please mute our mics to begin with. So if you can please mute your microphones just so we don't get too much background noise. Now, I'm assuming everyone can hear both Heather and I clearly. All right, perfect. Now, Heather, can you still hear me? Oh, I lost Heather.
I muted myself.
Oh, okay, that's fine. Okay, all right, no worries. Okay, perfect. All right, well, thank you everybody for coming tonight. So my name's Rhiana, and I'm a genetic counsellor. So I've been working in the genetic counselling field for about the last 2 years. So I graduated from my master's a couple of years ago, and I'm working based in Melbourne at the moment. And I've also been on the SWAN committee since sort of during my master's course. And so it's been really great watching and seeing SWAN grow and develop in these last 3 years. We've become quite a big organisation. I feel like we've taken a big leap in what we do and what we can offer families as well. Now, this session is really for everyone to ask questions. We thought we might use the chat function on the meeting app. So to ask questions instead of everyone talking over each other, it might be a bit easier. And I can see that everyone has just said that they can hear, so that's great. Okay, and then Heather will read out the questions and we can go from there as well. So I guess just to start with today, I guess I always like to start with, is genetic counselling. So I'm hoping that many of you may have had some sort of... Heather, you right?
Yeah, sorry.
Okay, perfect. I'm hoping that many of you may have had some sort of contact or may have some contact in the future with genetic counselling. And I guess, the way we define genetic counselling is, it's a communication process which sort of helps individuals and families understand and adapt to the medical, psychological and familial and reproductive implications of genetic contribution to disease in particular, or to specific health conditions. And so that's really where we base our practice off, specifically sort of genetic counsellors trained in Australia as well. All right, so let's just see if this all works. Perfect, okay. So genetic services in Australia. So there's genetic services all across Australia, and if you are looking for your local service, I do recommend the Centre of Genetics Education website. It's got a really nice list of genetic services to look at. In particular, you'll find genetic services inside or within hospitals, so within the public health sector, but there are also some private genetic services out there as well. And so the teams in the genetic services is really typically made up of clinical geneticists and working alongside with genetic counsellors as well. And then other types of genetic services, there's some that focus on paediatrics, there's some that focus on general genetics, and there's others that focus on family cancer as well. So I work in a service that focuses on quite a few different things. So that's a really great opportunity for us to interact in. Particularly, we began in the family cancer setting, but more recently I've been working in sort of the general genetics and paediatric settings as well. And we've been doing a lot of work around whole exome and whole genome sequencing, so we'll get to that as well. Okay. So rare diseases. So we know that approximately about 2,500 SWAN children are born each year, and about 6 to 8% of the population overall has a rare disease, and the majority of these rare diseases affect children. Okay, so now in this day and age, we have a range of different genetic testing and genetic testing technologies that can assist us in understanding a diagnosis for many individuals. But about 40 to 50% of SWAN children at the moment will still remain undiagnosed after genetic testing, or particularly genomic testing. So what I thought we might do tonight is, I've seen up on the SWAN Facebook page a lot of questions around genetic testing and which testing, so the differences between the different types of testing, sort of the step process for testing as well. So I thought we might talk about and just go over the different types of genetic testing that people may be offered. And in particular, not exactly the exact testing technologies, but more so what those genetic tests, what sort of results they might give us as well. So I think the best way to start when we talk about genetic testing is our genetic material and what is it. And so it looks a little like this. I'm not sure if many people have seen these sorts of diagrams. But we start with our DNA, which makes us who we are, and our DNA is packaged onto these things called our chromosomes. Okay, and so the way I like to describe our genetic material is a bit like this. So our genes are like our recipe books, and we all have about 20,000 recipe books. And our recipe books are packaged onto our chromosomes or our bookshelves, and we all have 23 pairs of chromosomes. Okay, and so our pairs of chromosomes, or 23 pairs of bookshelves, they make up our library or our genome. And it's really good to have a good understanding of this when we start talking about genetic testing, because different types of genetic testing might look at the book, whereas other types might look at the bookshelves, or more recent technology looks at the whole library as well. So there's many different types of genetic testing, and they can sort of be broken into sort of broad categories. And so we'll go through the different categories, and if people have questions as they come up, I'm really happy to answer them, but we can also get to questions at the end as well. Okay.
Oh, Rhiannon, there was just one question. I don't know whether other people can see this chat question about the 2,500.
Yeah, I just had a look. Yeah.
Children. So we base that on the UK, which is probably a conservative figure of 6,000 children born each year in the UK. So if you extrapolate that out per population, we get 2,500 or thereabouts.
Yeah, thereabouts. That's right. Okay, thanks for that, Heather. So when we think of types of genetic testing, so I guess the first type of genetic testing, and some people may not have heard of this one, is something called a banded karyotype. Now, this is no longer a routine test, as it's really less specific and doesn't really provide much information compared to current other or newer genetic testing technologies. So this is sort of what our chromosomes look like under a microscope. So this is a male, because we can see at the bottom the male has a copy of an X chromosome and then a copy of a Y chromosome, which is the chromosome that makes it a male. And so you can see all the chromosomes are numbered and they come in pairs. And so this G-banded karyotype, this is sort of what it looks like under the microscope. And really this test has typically been used to diagnose Down syndrome. Now, generally, it's also ordered when there's a history of miscarriages in a couple or a family, and that can sometimes be an underlying genetic cause. But typically, in terms of diagnosing someone with a genetic condition, this is not sort of a standard test that's arranged anymore. So I think the big ones come up typically about chromosome microarrays and Fragile X testing, particularly on the SWAN Facebook group. So a microarray is really the first step in genetic testing, and it's generally Medicare funded for an indication. So that's been a really great advancement, having this type of testing Medicare funded. And it's typically ordered by paediatricians or sometimes a genetic service as well. But it is definitely a test that paediatricians can order and will typically order and then potentially refer on to a genetic service with those results. So it's a good first test. It detects the likely cause of developmental problems in about 15% of cases referred for microarray. And then the other testing, which is Fragile X testing, the reason we test for that is because we know Fragile X is one of the most common causes of intellectual disability. And so for that reason, all children generally will have a chromosome microarray and a Fragile X test offered as well. So with microarray testing, so typically it might be ordered on a child, and then you'll also find that sometimes parents will have the same testing arranged, and that's usually to help us in understanding perhaps a result that has come up on that type of testing. So these are the sorts of the results that come up, and they can be a little bit confusing, and I think Heather and I were talking about trying to unpack these a little bit today in terms of what they mean. So you might see things, and the way we read them, so we've got 22q11.2 deletions, And we've got other ones there as well, and the dup stands for duplication. And so I popped down the little corner of these next few slides, which section of my explanation of our genetic material we're talking about. So in this section, we're talking about the bookshelves or the chromosomes, okay? And so our chromosomes, it's important to understand how our chromosomes are structured in order to sort of understand the types of results our chromosome microarrays may give us. So our chromosomes look a bit like this, and the important parts here is that they are joined by a centromere, and that joins the two arms of the chromosomes. All right, so we have the P arm, and all P stands for really is petite, so it's a smaller arm of the chromosome. And then down the bottom we have the Q arm as well. And so then the ends of our chromosomes you might have heard of previously as well are called our telomeres, but in these cases for these results they don't really come into play. It's mainly knowing that a P stands for the small arm and the Q stands for the longer arm, or the arm down the bottom typically. Okay. So each chromosome is then divided into regions or bands, which can be seen using a microscope and special stains. And then within the bands there are subbands. So a little bit like this here, we can see on the left-hand side it has the arm, so the P arm or the Q arm, and then it's broken down into regions and bands. So and you can see down the bottom as well, this is referring to chromosome number 1. Now, this is where these results come in. So if we want to break these results down, if we're thinking about the first section, that's just referring to what chromosome number it is. Okay, so we've got chromosome 22 here, so 22 out of our 23 pairs. And then the Q just refers to the Q arm, so that longer arm of the chromosome. And then the 11, the 1.2 refers to the band or the region of that chromosome as well. Okay, and then the last section refers to a deletion of the genetic material. Now we've got some questions coming through, Heather. Yeah.
Oh, so I was just going to say, Sharon had a question about. Oh, hang on. It was originally, how long has the test occurred for? And I said, do you mean microarray test? I've now worked it out. Oh, some of our children had these tests done a few years ago. Okay.
Yeah. So microarray testing has been around for a little while now. And it's more
just
recently, I guess.
It's actually Sharon here. Some of our children are older, and I was just trying to work out exactly what testing Jazz had. But as you went into the microarray results, I realised she did have that testing when she was 11, and it took a while before they actually did that type of thing. So it's all good.
Yeah, that's right. Yeah, and they're very distinctive results. The way these results are worded, they're not like any sort of other results. So it's helpful in how to understand that. Yeah. Okay. Thank you for that. And so the last section we were talking about refers to a deletion of genetic material. So if we're thinking about chromosomes like bookshelves, when we get a result like this, we know that on bookshelf number 22, on the Q arm, so the sort of, let's say the bottom, the lower end of the bookshelf at, shelf 1.2, there's been a deletion or a removal of some of the shelves that we would normally expect to see, okay? And the reason that's important is because our genes or our books are packaged onto these bookshelves. So some of these results that we get on chromosome microarrays, we can get many different types of results, and some of them have been seen before. And so in this case, an illustration of what it looks like is we have a chromosome, and we've got 2 breaks in the chromosome at that point, and then we've got some deleted genetic material, so we end up with a different looking chromosome. And so this is actually a known genetic condition, otherwise called DeGeorge syndrome. Okay. And so then, on the other hand, we have other results. They can get a little bit more complicated when we see lots of different numbers, but when we break it down, we're again referring to chromosome number 4 in this case. And we've got the Q arm of the chromosome. And then this section here is the band or the region. And then we're just referring to a deletion between those regions, so between Q28.1 and Q28.2. So that's all those numbers really mean when we break them down. It's just really a way of us, I guess, as genetic testing laboratories and genetic health professionals to work out the exact pinpoints of these genetic changes or removal or additional information may be on the chromosome. And the reason that's relevant is because different genes sit in different sections on these chromosomes. And so then we can work out what genes might be affected by a genetic change such as a deletion. Now, do we have questions coming up about that, or?
I can't see any, but does anyone want to type a question?
No, that's fine. We might get some more later. Okay. All right. Oh, no thanks. Okay, perfect. Okay, and so all right. So the thing with microarray results is that, in terms of our genetic material, we all have lots of different spelling mistakes or genetic changes or pieces of information missing or extra pieces of information. And you'll find it very common with microarray results that sometimes the results that come about on a microarray test are hard for genetic health professionals or paediatricians or anyone to interpret, and particularly the laboratory to interpret, because they may not have been seen before. And so this is typically where we've got someone with a question. Okay.
I don't know what happened there.
No, that's okay. No worries. Okay. And so getting back to what I was saying is this is why forensic testing is really important. So may be tested to see whether they carry that same chromosome microarray change. And if they do carry that same change, then depending on what that change is expected to bring about, we might be able to say that that genetic change is likely to be an explanation. And yes, Jasmine, I just saw your question as well. It is the same for a duplication reading. So say in this case, if we had the 4Q28.1Q duplication at the end, it just means that that region of genetic material has been duplicated. So I hope that answers that question, and let me know if it doesn't.
And
so it just means
asked about triplication.
Yeah, so I haven't seen many triplication results on a microarray.
Neither have the specialists.
Sorry, neither have the specialists. Yeah, and that's where it makes it really tough, because if many of us haven't seen it, then it's a bit of trying to understand what we do and how we interpret that information. But I would assume that would be extra genetic material on top of that duplication. But when you break down the result, it would be quite similar, except for the triplication. Okay. All right. So microarrays is sort of the first point of call usually. And it's something, like I said, something that pediatricians regularly arrange, and they commonly refer on to a genetic service to help with the interpretation, and especially in those cases where the significance of a genetic change is uncertain as well. Okay, so we'll move on to the next section of testing. All right, perfect. So the next section of testing is what we call panel testing. And so when we think of panel testing, we're thinking about the books on our bookshelves. So we're thinking about specific genes. And so multi-gene panel testing is sort of a type of genetic test that looks for genetic changes or mutations in several genes all at once. And so these genes are usually grouped onto panels of sort of similar conditions or similar presentations as well. Okay, and so it's the same with these sometimes as well. When we get results from these types of testing, sometimes it's really difficult to determine whether a change in that gene or that recipe book is going to bring out a change in that individual. And this is where testing of parents may happen as well. And the reason, you know, we think about genes like recipe books is a good illustration of if there is a genetic change and you change the recipe, you know, if you add an extra teaspoon of sugar to the recipe, then the product or the cake that you get at the end is not going to be very different. But if you add 10 teaspoons of salt into that recipe, then the product or cake you're going to get at the end is going to be very different. Okay, so we all have little spelling mistakes in our recipe books, but the question and the things that the laboratories and we as genetic health professionals try to do is try to understand how is that changing the product of that gene and how that gene works in our body in the end. So panel testing is typically ordered generally, so it's ordered by genetic services and it's typically ordered when a geneticist in particular suspects a particular type of condition. And I guess until recently it's been sort of the best form of testing to be able to test for sort of multiple things at once. But like I said, it's limited in the sense that it is grouped into certain conditions, but it's a very good test if there is a particular condition just based on sort of clinical presentation that a clinician may be interested in looking into. Okay. And so an example of a result that we might get on a panel test looks a little bit different to a microarray result. So when we're looking at the spelling mistakes in our genes compared to the spelling mistakes on the bookshelves, they read quite differently. So this one here is an example. So we've got an ARID1A genetic change. And now when we think of our DNA and our genetic material, our DNA is made up of these things called base pairs. Okay, and they're in different combinations. And so this is just telling us what base pair change there has been. So there's been a change from a T to a G. And then it tells us how does that change that recipe, or how the protein is made up from that gene. And so that's a known genetic condition, otherwise known as Coffin-Siris syndrome. And so we need to look at these spelling mistakes or genetic changes and determine whether we think there's something that's actually affecting that recipe book and actually bringing about that condition, or whether it's what we call sort of standard or population variation, because we're all different. Okay, so the next section is our exome and our genome sequencing. Now, I'm sure many of you have probably heard of exome and genome sequencing, and it's really come about in the last few years, more so in the clinical setting. Previously, it's been really very much offered in the research setting, but more recently there has been sort of some funding, some government funding. I know in Victoria there is to facilitate whole exome or whole genome sequencing. So in this case, when we think of this exome and genome sequencing, we're thinking about our library, which is our genome, but also the books within that library as well, so the genes. So one way to think of our exome and genome and how they're different, and many people might have seen this illustration before, is our exome makes up about 1.5% of our genome. And the difference between the genome and the exome is the regions of the that are involved in the exome are the regions that code for things. So they are really the recipe books or the coding regions of our DNA. And so that's why we typically, when we're talking about genetic testing, a lot of the time whole exome sequencing will be arranged rather than whole genome sequencing. And there's a few reasons for that. One is that, you know, there's a smaller amount or more concentrated amount of genetic material in the exome, and it's easier for us to interpret that information. And it's also sort of the most useful, and it's also lower cost as well, because the interpretation of that information is difficult but more straightforward than looking at a whole genome. And it can also be a bit faster than whole genome testing as well.
Excuse me, Rhiannon, there was one question from Christy. If an individual has a duplication, can they have variants in the gene too? Can you see that
That's a
one?
good question. Okay, so yeah, so I think, Christine, hopefully I'm understanding your question right. So in the sense that there's a duplication on a chromosome microarray, look, I would say yes, but obviously it comes with, you know, depending on what that duplication is on that chromosome microarray, is that an explanation for an individual's health problems, or is it not? And if it is an explanation for that individual's health problems, then there may not be further genetic changes in the genes that could describe that. But if it isn't, then there obviously definitely could be further genetic changes in the actual genes as well. And I hope that answers that, and please let me know. A duplication of unknown clinical significance, I think you've just said there, Christy. Yeah, so I think that's difficult. And this is why we talked about generally what we do. If it's a duplication on a chromosome microarray that's of unknown clinical significance, generally there's parental testing as well. And if a parent carries that, then that's something that we can say that, you look, maybe we're not as suspicious of this providing an explanation. But in the case of unknown clinical significance, it is hard to definitely say whether it is causing. Okay, yeah. And yeah, so that's, yeah, so sorry, Christy, I've just noted your chat message about what it is. Yeah, and so that's the other thing too, our genetic conditions and the way our genes and sections of our genes work, or our bookshelves as well, is that not everyone expresses it the same way. And so it is difficult sometimes to determine whether a genetic condition or a duplication or a change in one of the recipe books may be what we call sort of penetrant in both like the parent who carries it and the child, or it might be that they might sit on a spectrum of different sort of symptoms as well. So I'm not obviously certain about your specific case, Christy, but in that case it would be definitely something for a genetic service to unpack. Yes, and I've just read a message about, is this why two children with a similar genetic mutation could be completely different? And that's quite right. A lot of our genetic conditions work on a spectrum or like a scale when we think about it. And there are some individuals that could be present different sort of clinical symptoms to other individuals as well. So yes, that's quite right. So hopefully that answers that. Okay. And yes, so severity can vary as well. And obviously this is very dependent on which condition and which genetic change. But, you know, when you think of other things such as like autism is a spectrum. And we know that it can be different as well, and people can present differently along that spectrum. Okay. All right, so we're getting quite a few questions.
I'm trying to finish typing. I was just going to say, I know you guys can't put a finite answer on something that you're not quite sure of, because like I joined SWAN because Jazzy was the only one with a triplication in her area, and there wasn't much to compare with, and there still isn't. So, and I hate the frustration, and I've seen it with a few others, SWANs or uniques, that you have to go specialist hopping and you're sort of not believed quickly enough before the medical condition worsens or something happens, because you guys can't give a finite answer and there's no history. So the specialists say, no, you've got to go to this specialist. No, we're not going to quite put it, no, we're not going to treat it that way. Our geneticist actually sent a letter with us saying you have to treat the symptoms as they are, as they present, not what you think. Like, it's a great big snowball effect. And is there any way with this new genetic workup, like the last with the exomes and all that type of stuff, that it could be helpful in any way?
Yeah, and it's a really good point. And I think, you know, we as genetic health professionals, I think you've touched on a point there, you know, we sometimes, unfortunately, we don't fully understand things and we place this, you know, uncertain label on something, but then when you translate that to other specialist areas, it is difficult for them to understand and to know how to treat someone in a certain way. I think we're going to get lots of unknown things that come up, and we do in whole exome and whole genome sequencing. But the more individuals that have this sort of sequencing, the bigger and better the databases and knowledge is going to get. And that's ultimately how we interpret the genetic information. And there's lots of different ways that laboratories interpret genetic testing results, but one of it is looking for sort of other cases or other documentation in the literature or databases as well. So I don't think it's necessarily going to make it better or clearer straight away, but I think in the long run, if we can build this information a little bit further, that's going to sort of lead us in the right direction. But I can appreciate it's very frustrating and frustrating for us as well as health professionals to not be able to give a definite answer and to not be able to fully unpack or understand something. I can definitely appreciate
just the whole, I mean, I don't know about any of the others that are listening. The snowball effect of that type of thing is that even you have family, you have everything that doubt. You know, one specialist says, yes, they definitely have. Then another specialist will say, oh, no. And then, like, trying to even get a para-equestrian grading, you've got a neurologist saying she has a different type of spasticity to, say, someone that has cerebral palsy, but she still has spasticity. And then the grader says there's no such thing. And then you go back to the neurologist, and the neurologist goes to kick you out of the thing. It's this whole, everything has to have a name. And when you don't have a name, you're in this type of space.
Yeah, and it's that real sort of diagnostic odyssey that you know, SWAN families are constantly living, and I can appreciate it's, you know, frustrating when health professionals are giving you different answers, in particular in specialists and, like you mentioned, neurology as well. I think sometimes you know, we don't understand everything. And I think sometimes it's really difficult for specialists, but at the same time, I can appreciate having, you know, differing and conflicting views is really hard because you don't know, like you mentioned, touched on family there. What does this mean for, you know, not your like sort of your immediate family, but also other family members as well. And what does this mean for your child growing up too as well?
Yeah, it's and I mean, I don't know. There's a couple that have had duplications that I'm listening to and stuff like that, and I can hear that they're starting frustrated. My daughter's now 19, and even the school system and not having a proper diagnosis and stuff like that. You know, she does have, you know, generalized background brainwave slowdown and all this type of stuff, but it was never put into, you know, these things weren't discovered until she was 14 or 15. Even though I had a baby that cried for 36 hours non-stop. You know, those type of things. And then you have the school, and everyone these days thinks they know how to parent better than you. And it just causes a lot of hassles for people. And I don't know, as geneticists, I've found that you were the closest to understand, and whether there's some way of putting more finite reasons into place when they are SWANs to say, you know what I mean? It's just this whole
I completely know what you mean.
Misbelief. And the only people we can turn to really are the geneticists, in a way.
Yeah, and I think geneticists and genetic services have a big role to play in advocating for SWAN families in terms of how they access, you know, we're interpreting genetic information. A lot of the time you may have, there's possible some of the time that you may have a result that's of uncertain clinical significance, but the geneticist may have a feeling just based on their experience and the presentation in that role, then they have a role in communicating that to other specialists and advocating for the families for what we think is happening in terms of the genetic side of things. Ultimately, specialists treat the symptoms that they've got a lot of the time, and they're the ones who are expertise in that area. Yes. And so I've seen a few more questions come through.
I think that's what, it's the whole frustration. And the counsellors, because a lot of them are you guys are super busy and super stretched, don't have the time enough to give that we need. Like I went back a few years ago when Jasmine was on one of those merry-go-rounds of being really ill and stuff like that, And they said, well, we can't give you any answers. And I thought we had someone that might have been similar to her overseas or whatever. And they said, we don't want to see Jasmine really until she's going to have children, if she's going to have children. And I sort of thought, hell, you know, it doesn't, genetic counselling, genetics, where else do we go? And it's our GP who's getting ready to retire shortly. And that's it. So, and I mean, these guys are, some of these are only just starting their journey. And we're 19, and I've gone through school. This system is the worst system, I think. It's just so hard, the system.
Yeah, it's really hard, and I think it's constant barriers that, you know, that are being placed and sort of put up. And you mentioned as well that this idea of needing a diagnosis is a way to define how someone is managed, and in the school system as well. And I know sort of with NDIS and all of that, there's a lot of questions about, well, what is the exact diagnosis? And there's a lot of weight placed on genetic and genetic diagnoses, but I completely agree, you know, genetic areas, we are all looking to be more resourced, and I see many cases where, and a lot of families will experience this, where you may only see a geneticist and you might not get to see a genetic counsellor. And I know that a lot of services in Victoria are quite aware of this, and we do see the benefits of families seeing a genetic counsellor, particularly, Dee, with your comment there, that genetic counsellors probably play a really big role in helping to explain and also help families sort of understand and adapt to when there is no result, instead of just sort of a result being delivered and the family walks out the room. And so a lot of us, including our service and other services, are looking at sort of moving forward what other models might work. Should genetic counsellors be completely entwined in that process with a geneticist, and how do we resource that as well? Because ultimately a lot of the time, unfortunately, it does come down to resource and government funding, which is difficult.
Yeah, which is the system again.
Yes, that's right. We're all doing the best that we can with what we've got, you know, genetic services.
And you can't do any more than what you can. Use a stretch. We understand that. I think a lot of them are frustrated with the whole system. And to be honest, SWANs, we don't have the Cerebral Palsy Alliance. We don't have anything like that to go to, or that type of thing, or Down syndrome or something like that. We have ourselves, and that's it. And SWAN is it. So
and I think, you know, just being on the committee of SWAN as well, I can see that, you know, in the last 3 years, like our membership and what we do has grown and developed, and I hope that, you know, in the future, and we do currently do this, is advocating for policy and development and changes. And I know Heather works really hard around that. And, you know, I hope that we can sort of lead that direction in the future, because I don't know, and with the support of genetic services as well, and we're lucky at SWAN that we do have support of a lot of genetic health professionals in Victoria that support us. And then hopefully with that we can build some momentum to help try and, you know, make suggestions or changes or go from there as well. Now, Heather, I'm just noticing a few questions coming up. I don't know if I've addressed them all, so please pipe up if I haven't addressed your question. I've missed a few.
Sorry. Dee's, look, it's hard. You might just want to look at Dee's last question. It is really difficult when you don't have an answer and no one can give you certainty.
So
I don't know whether you might want to talk to Dee more offline, Rhiannon. I'm not sure.
Yeah, I'm really happy to.
Are you okay with that, Dee?
Yeah, that would be good. So in my last conversation with Felix Oberender, the director of the PICU at Monash, the Monash were attempting to get a meeting between myself, my husband, Associate Professor Michael Fay, and the genetic counsellors. Because if they do believe, obviously, that Amaya had a mitochondrial disease, that's definitely something we need to know about heading into the future. Particularly if the mitochondrial mutation, if her mutation or issue was in her mitochondria, as that will mean that I am the carrier. And I obviously, you know, 29 years of age, I need to know things like that for my future.
mitochondrial, they've identified like 300 causes of the disease, I believe, but there's a lot more they still don't know about. So it's not always an easy diagnosis when it's a mitochondrial disease.
Yeah, and that's the thing. Through my own research, I've seen a lot that there is quite significant amounts of mitochondrial diseases. A lot of people are capable of living with them, but obviously in Amaya's case, she was on the more severe end of the scale. And that, you know, two people with the same mitochondrial mutation can have completely different symptoms as well. So I know that it's going to be a really difficult thing to try and interpret and understand. I guess from this, and particularly from you, Rhiana, if you could, I just probably need more knowledge around the actual genetic counselling and or where do I go next? What questions do I ask next? That sort of thing.
No, I'm really happy to do that, Dee. If you did want to do that, very happy to. So I guess, you know, I can talk briefly to the genetic counselling process, but I think in your situation it might be a little bit different just because you've had that initial trying to draw teams together in that area. And so I would really, and I don't know, you know, maybe this is another forum for this actually to talk about where you're up to with that and how it would work from there. That might be a little bit easier.
Yeah, I think that would probably be a good idea too.
Yeah, maybe Dee, I could put you in contact with Rhiana and she could put you in the right directions.
Yeah, that sounds good.
Okay. No worries. So I did just miss a question up there. I think it was Janine about a database, and a database only being as good as the current person or technology who creates the software, and that's true. When we do interpret genetic testing information, genetic testing results, the way the laboratory interprets results is it's a very multidisciplinary approach, and it doesn't just use databases. So I know in Victoria we have, you know, a multi sort of a MDM or an MDT meeting for the curation of genetic variants that involves geneticists, sort of bioinformaticians, genetic counsellors, specialists in that area, so whether it's sort of a neurological or suspected neurological condition, and they look at what is out there in the databases, they compare to in the internal databases, but we also look at what is the effect of that genetic change on the product of that recipe as well. So there's a lot of different combinations of factors. In terms of databases, there are a lot of good databases there, but they're only one aspect of things that are taken in to account when you see a genetic testing report or a curation of a genetic variant. We're looking at lots of different other factors that are being taken into account as well as the clinical presentation of the patient in front of us as well. Okay. Now, Heather, we've got one more. Sorry, I'm just trying to keep up with the chat, guys.
Oh, there was one about microarray versus and whole exomes, found a chromosome deletion and gene variant from Jamie. Can you see that one?
Yeah, I'm just having a quick read. Sorry, bear with me just one moment so I catch up. Yeah, it's a good question. And obviously, you know, and I say that everything that I talk about, I guess, is with a caveat is I don't know all of your individual children and their symptoms and the way they're presenting. And obviously, the best advice can be sought by your local genetic service. But sometimes, you know, whole exome sequencing is really good technology, and we're getting a lot of diagnosis with whole exome sequencing, and we've seen that a lot in SWAN as well. Whole genome sequencing is looking at more things, but whether we're definitely going to get more answers or whether we might get more of those uncertain findings, we don't, I guess, know. It's likely we'll get more of those uncertain findings as well, and it is difficult sometimes when we find a genetic change or a gene variation that doesn't fit with the clinical phenotype, because we don't want to give I guess one way to think about it is we don't want to give a certainty. We don't want to say, yes, this is an explanation if we think it doesn't fit, because there could be something else out there that we're missing. And whether other technologies might pick that up, that's possible. But yeah, I'm not certain. It really would depend on the presentation and how, you know, whether it's something that we are thinking that does fit with something we might know about already, or, you know, whether our genes is something in our genes that we're going to learn more about in the future. Okay. So I had another question, Heather, I think, and I don't know if we've touched on stuff from that came in earlier.
Oh, did I miss something?
No, that came in previously. Today, you sent one through to me.
Oh, yep, hang on, I just have to go to the phone.
That's all right, I think I've got it in front of me. So we did have a question earlier today that was sent through talking about microarray testing, and if something had been found on a microarray test, is there any benefit in pursuing whole exome testing as well? And in this case, the individual has said that in this case, they're talking about something that's called a pathogenic duplication. And so a pathogenic duplication, the word pathogenic just means that we're confident that it sort of brings about a health condition as a result of that genetic change on microarray. So again, it's going to be what fits with the clinical symptoms, I guess, of the patient in front of you. And so if microarray testing has found a pathogenic duplication that the geneticists and the genetics team think fits with the clinical presentation of a patient, then there might not be further benefit in pursuing whole exome sequencing. But like I said, it does just depend on the clinical presentation and the genetic health professionals' interpretation of that result in the context of the presentation. So, but look, many people will sometimes get a diagnosis on microarray as well, and that's why it is the first sort of line of testing that's done. And then the question went on to talk about whole exome sequencing and whether it's offered publicly or privately. Now, I don't know exactly what it's like in other states, but I know in Victoria there is a certain level of funding that's allocated for whole exome sequencing at the moment, and the way for families or for an individual to qualify for that, there needs to be a number of consultants to agree, and that's quite a complex tiered system, but it needs to be a number of consultant clinical geneticists who agree that a case fits into a certain type of category in order to access some of that funded exome funding from the government. But and so that's one way that it's done. Other times, you know, generally when whole exome sequencing is offered, it's generally because we think we're going to that the chance of finding something is reasonable, and that's generally when it's offered. If we think that, you know, it's not going to find anything, then it makes it a bit harder in terms of the funding side of things. So that's sort of the publicly side of things, and also genetic services themselves have a certain budget, and some of that budget may be allocated that's not specifically allocated from the government for exome sequencing, but it might be part of their own genetic testing budget. And so some genetic services may have allocations from their budget for that type of genetic testing, and they would have sort of criteria to fit that. All genetic testing generally can be accessed privately, but it generally needs to be accessed through a private genetic service. And so there are some geneticists who do run private practice as well, and then that would be paying for the sort of private consultations, followed by privately funded whole exome or whole genome sequencing. There was a question about companies, so I'm wondering whether that question about what sort of companies offer this in the sense of private testing, whether that's the sort of the actual genetic testing companies, or whether it might be private genetic services. Now, someone would be interested in information about private services. That's an option available, but the companies, you know, there are so many good genetic testing companies out there, and there's more and more appearing all the time. There's quite a few based in Australia, but there's also some based in America, and many sort of Australian genetic services may send their testing to America as well. But the other thing as well, and it depends on the genetic service, is you can privately fund testing within the public system as well. So it would mean that, and I know some services do this and other services don't, where in the case that a service or the government is unable to fund further genetic testing, individuals can fund that through a public service, but just paying for the actual testing themselves. So I hope that clarifies that a little bit. Do we have any questions that are coming up?
Yeah, there's one.
So I'm just going to have some water.
So there was one.
Okay.
Oh, hang on. Have you done that one? Sorry, just lost it. Oh, Nicole had a question. We had a microarray which found a deletion, but my daughter has so much more going on than what was explained with the deletion. What further testing should be looked into?
Yeah, so my question there would be, obviously, you know, I'm hoping you've seen a genetic service who have talked about that deletion and what that would mean or what type of clinical presentation. And if a genetic service or genetic health professional are suspicious of something else that could be an underlying cause, and it depends obviously on the clinical presentation, but perhaps if they have an idea of a type of condition, panel testing, or perhaps whole exome sequencing as well. Yeah, it really depends on the clinical presentation. And
there's one more question from Preeti. Can you read that one, Rhiana? In case of my daughter, the geneticist requested for a whole array of panel testing before they would consider whole exome or whole genomes. Eventually, or whole genomes, found a variant with a nuclear encoded mitochondrial gene panel analysis would be worth, after something like this, is still try to pursue whole exome sequencing.
Yeah, so I guess my question was just reading that is a variant, and we use different language in genetics sometimes. So variance is just sort of anything that's different from the reference gene or the reference genome. In this case, are we talking about a variant that has been found that is a variant that's known to provide an explanation, or is it a variant of unknown clinical significance? If it's a variant that's pathogenic or known to provide an explanation, then perhaps an answer may be there, obviously, again, depending on clinical presentation and what that variant is. Or if it's a...
Sorry, yeah, so,
yeah.
Hi, sorry, it might be easier rather than typing. But,
no, that's fine.
So they did find a variant and they isolated the gene to a particular gene called CARS, and there is some research, it's a very rare gene, apparently,
okay.
that it's pathogenic in the research. But I just wondered, is there something more that, like, should we have tried to pursue more further testing, or would that be sufficient for us to say, yep, that's definitely what it is? And because the research shows that there is a possible reason for this particular gene to be pathogenic, then should that be considered as, yep, that's it and closed case? Or would there be added benefit on doing exome sequencing or genome sequencing?
Yeah, and I'm assuming you've been sent through a genetic service for that?
Yeah, just here in WA.
Yeah. No, okay, good. Yeah, so I guess it really depends on whether that variant fits with the presentation that you're seeing, and the clinical symptoms and signs. Thing with variants is, like you said, some research areas might say that there is that it does provide an explanation, or that it may be evidence that it's pathogenic, and it might just be that we just need a little bit longer to know that. Unfortunately, sometimes it takes just a little bit longer to say, yes, look, we're confident that this does completely fit with the clinical presentation and is, in the literature and databases pathogenic. But like I said, it really depends on the symptoms and the signs and everything else that we really think. Yeah, and that's where
I guess it would be the whole clinical picture, isn't it? So I suppose that's what they would be looking at. Yeah. Okay. Thank you. That's helpful. Thank you.
No worries at all. Okay. Yes, and Heather made a comment there. There is less waiting time for private genetic services, and the waiting time in our genetic services really just comes down to resources at the moment. And whether you can, hire another geneticist when geneticist leaves, that's really what it comes down to. Okay. Now, do we have any other questions coming up?
I have a question. I'll go.
No, go for it.
It's Sharon again. Just a quick question.
Yeah.
I think these guys have got younger children than Anne. Jasmine's 19. She's into para-equestrian in a big way, right? And these guys will come across it if they want their kids to do anything different or go for their dreams. Now, the grading they want finite things that go under grading for para-equestrian, all that type of stuff. When people go to things like the Cerebral Palsy Alliance, Down syndrome or whatever, they can go to a panel of people and get the answers they need to go and get these things done. Is there anything within SWAN or genetics or anything like that where we could go to and maybe look at a bigger picture instead of going to like 14 specialists for every little thing that she's got? You know what I mean?
So you're talking about like a whole picture approach to the genetics, the sort of clinical presentation and all of that. Is that what you're talking about? Or
yeah, and having they have to have, unfortunately with life, they have to have finite answers to a point in order to, you know, gain access to medical, you know, all that type of stuff. You know what I'm talking about.
Yeah, no, and I think
para's the same. Now, yes, they've put us through at this stage, but they want more of a finite answer later on. And I'm sort of thinking, well, maybe I'll talk to you guys at SWAN to see whether there's something where us guys that don't have an umbrella to go to, is there anything set up, genetics or anything like that, that we could go to get that type of thing?
Yeah, and I think you've pointed out sort of a fundamental flaw in a lot of the systems in our country and many countries, is that there is so much weight placed on that finite or that diagnosis, and so many individuals and families just don't fit into that umbrella, and unfortunately a lot of the time may just not fit until we understand and learn things further. The things about those other organisations, and Heather, feel free to jump in here.
I'm typing something about lobbying NDIA for better outcomes for rare conditions.
Yeah, beautiful. Okay, I was just going to say the things that those other places like cerebral palsy or Down syndrome Victoria have ahead of us is they're conditions that, especially Down syndrome, are very well understood, and the genetics of them are very well understood. And the number of people diagnosed with that condition puts more, I don't know, money, drive, funding behind that as well. Would you say that's,
yeah, and these
that's true. That's true. I concur with the two of you with my own experience.
And they have a lot more staff.
Yeah, they have a lot more funding, they have a lot more staff, and they do have a lot more, what can we say, cases to study off and concur with. So,
yeah,
you know, it's a lot easier for them to sort of hit the bullseye with it.
Yeah, that's right. Yeah.
And it's just, I mean, there's Unique over in Britain.
The UK.
I don't know. I haven't been there. I don't know how well organised it is there, over there.
Unique's very well organised. I think it's been going 20 years, and you know, they've got, I can't remember how many working for them. I think it's about 6 or 8 people, but they have a set formula for how they produce their information, but they don't do individual genes. It's more chromosome disorders. So that's where they're a little bit different.
It's like microarrays, Heather, isn't it?
Sorry?
It's more chromosome disorders, like results. Yeah.
That's right. So not individual gene. And look, I mean, you've got Global Genes in USA, you've got SWAN UK, but they tend to do more of the undiagnosed, not the diagnosed banner, whereas we're trying to juggle both rare conditions, which there's no other peer support group for, as well as undiagnosed.
I found there was a way with NDIA. I found with the agency, they did not look at Jasmine's overall health and intellectual and autistic and all those type of things that she had. They only had her listed as one. But then when I went sort of more privately and went to them and said, hey, she has a genetic triplication, this is her last whatever, and we went through and listed everything, that's when her funding changed. And unfortunately, I think that is the only way you're going to go. You're going to have to do what we did. We had to go around to all the specialists at first and get it. And I asked the geneticist and everything, what do I say when Jasmine's condition is? And they said, just say it's a genetic triplication. And that's all you can say. And
look, yeah, it's difficult.
And I mean, we went from something like 30,000 to 90,000 because they only put one thing, her intellectual disability, and it wasn't the correct one either, and that's all they had her under. And this is what the whole thing with the NDIA, the agencies are telling people what they should be doing, not the people saying this is what's wrong, this is what we need. And I feel that's another way of going. I don't know. I found that better.
Yep.
Yeah. Look, Sharon, I might do I've just written it down. I might do a session on that. We're about to do a submission to the National Standing Commission like for NDIA. So if you've got some ideas and you want me to include like your experience in them, just email me through by the end of the month, and we'll write that submission and try and include different viewpoints, because I think we can talk all night about the NDIS.
Yeah. But I mean, you guys, there's some people out there that have hardly got anything. So, you know, and it just there is some that are overfunded, and like
look, it's a new system, and what we might do is I might do a session on NDIS and how to get the best outcomes for rare disease patients. But what we might do, if you don't mind, I might, because I'm conscious of time, I might let Rhiana finish her presentation, if that's okay.
Yep.
Yeah, I'm pretty much done, Heather, I think.
Oh, have you? Oh,
yeah, I think I've been sitting on my left side for a little while, I think. My only thing was questions.
Yeah, the thing about, I was just going to get a finite answer. For anyone to get further sequencing or genetic testing other than the microwave, would really have to present with strong medical reasons to get that done, is my understanding. Is that right?
Yeah, and if there's not an explanation on that microarray as well. So if they've got if there's an explanation for clinical symptoms and clinical presentation on a microarray, then the diagnosis is generally there. And if there isn't an explanation, look, it really depends on the funding in different states. Generally, you know, funding is a lot better now than it was. And so individuals who present with younger children who maybe are considering to having more children, yes, they may be more likely to get funding, but, you know, I'm just sort of saying off what I have seen so far, and that's very limited to, you know, a couple of services. So I think the models are really different and they are changing, and the fact that there has been funding that has come through for genetic services to use towards exome sequencing has been a big step forwards. Yeah, and that's been recent. Yeah, that's right. Okay. Now, do we have? Not yet. Okay. So, if do we have any other questions? I think before we wrap up, Heather.
Look, I'm just. Yeah, that's all right. Do we need more evidence if we want to pursue whole exome privately, or if it's pretty straightforward? And Janine also had a question about genetic counsellors earlier not being available at private genetics clinics. Now, I don't know how it works in Queensland with private genetics services. Do you know? Can you shed any light on that?
Yeah. And I don't know exactly. I know, you know, genetic counsellors don't have a Medicare item number, and we can't work without a geneticist. And so for that reason, you know, genetic counsellors generally there's not, you know, a lot of jobs for genetic counsellors in the private area at this point in time. And a lot of geneticists will work on their own in the private setting. So a lot of geneticists won't have genetic counsellors entwined in their private setting. I know in Victoria we do have a few different services, but they're less, I think genetic counsellors at the moment in the private setting are less to do with sort of diagnosing genetic conditions, and more so in the terms of sort of family cancer or preconception genetic counselling. So carrier screening, preconception, there's a larger role at the moment for genetic counsellors in that area, I think, in the private setting at the moment, especially in Victoria.
So, Rhiana, so just with what you said there, so for someone like obviously me, so Amaya was completely undiagnosed at the time of her death, and their thought processes post her passing was that really the only way that they could explain it was that it was a mitochondrial disease.
Yeah.
In terms of carrier testing, how do, like, and this is, I guess, something that you and I can chat with as well. Is this something that we can readily access somehow, or does it have to be done through the hospital where she was cared for? Can we do it privately? Like,
yeah, no, it's a really good question. So
I don't even know where to start. There's literally nothing you can research, like, or Google, I guess, to actually even find where to go.
You're right.
And yeah, it's a really good point. So carrier testing, and the question of carrier testing. So carrier testing doesn't have to be done through sitting, face to face with a genetic health professional. And we're trying to, I guess, from a genetics perspective, get the idea of carrier testing out there. So carrier testing is for genetic conditions, so known genetic conditions where both parents might carry a genetic change that predisposes to that condition, and when a child inherits both changes and they may have that condition. And so carrier screening, it's always a privately funded test. So it's not something that's funded by the government at the moment. There are a few research studies and research groups going on carrier testing that do have some funding, but you can access GPs can arrange carrier testing, or you can also talk to, so the Victorian Clinical Genetics Service do facilitate carrier testing. They have a genetic counselling team that works in that area, and they help GPs facilitate that as well. And then if someone or a couple has a result that needs further genetics input, and then generally they're referred to a genetic service, or they can access genetic counsellors through there.
So at the time of her first arrest, when she was 4.5 months, so Michael Fay had her put on a trial to have her WES sequencing. So she had WES sequencing, her whole genome, I think. The only one that we haven't had, because Jay and I were both tested as well, the only one we didn't end up having was a whole exome, I believe, which is the bigger test.
The other way around.
The other way around.
Oh, other way around. Yeah.
Yeah, so genome covers the whole, all of our genetic material, where the exome just covers the coding or the sort of regions of our genetic material. Yeah.
Okay, so she would have had the exome and not the genome. So yeah, there's only that one left. Yeah. Nothing came back from all three of us. So is that going to lead to a situation where basically, even if we did go down carrier testing like road, they're actually not going to be able to tell me anything anyway? Yeah,
so the carrier testing road is probably not going. So carrier testing is just for known genetic conditions, and it's for common genetic conditions, common in some senses, that parents can carry genetic changes for. It would look at, I'd have to see sort of what sort of genetic testing you've had and how that would all work, but unfortunately, and obviously this is really, really case dependent, but, there are some cases where when we do get results on exome sequencing or we don't find anything, and then the question is being brought up in genetic services, is genome sequencing going to identify something that exome sequencing obviously did not? And genome sequencing, only some of the labs have recently started doing full genome sequencing, and so have just recently released their their tiered and payment system for that. And so, hopefully in the next little while, we might see what difference is genome sequencing making on exome sequencing. But at the moment, exome sequencing is the test that's done first because it's cheaper than genome sequencing. It's an expensive test, it's not cheap. And the results that we get from that are difficult to interpret, but it's not as expansive as the results that we need to try and interpret from a genome test.
Yeah. So, and that's why she then...
Yeah.
He then went on to do muscle biopsies, skin biopsies, and everything that he could potentially think of to try and get us an answer.
Yeah.
Yeah. No, okay. Well, it's probably...
very happy to chat. Yeah. And you can ask you a few separate sort of questions, I think, that might not be best for this moment. Yeah. Okay.
Yeah.
No, that's fine. Okay. All right.
Rhian, there were a couple of other questions. Christy had one about microarrays being out of date. I've just sent it through to you again.
I'm just having a look.
In the beginning, we were told my son's located genes were XYZ, but when researching recently, it appears the gene details have changed in this location, but I find it hard to get information about these genes. If the gene information is different now, could his microarray details be out of date? It was done.
I think the best question for that would be to ask for a review for a genetic service of that information, and they'll be able to tell you whether it's different or not. Obviously, it depends on exactly what genes are tracked to that region, and did they think that was an explanation in the first place, or did they think there was something missing that didn't provide an explanation for the clinical symptoms or clinical presentation as well. But I think, if you are finding other information, I know, most genetic services, yes, we are under-resourced, but would be open to discussing that. I know a lot of genetic services run with a genetic counsellor on duty, so you can give a genetic counsellor on duty a call, and then they're generally happy to discuss those cases with a geneticist and get back to you about that as well to see whether you might need a review or not. Okay. All right.
And then Carla was just asking one last question, which are the reputable companies to go through for whole exome sequencing? But I would say ask your genetic service if they...
Yeah, because there's lots of good companies out there. Obviously, different companies differ with, where they are located, what does they cost, and what samples they use versus the turnaround time for testing as well. So, but yes, genetic services should have an idea about that. And some genetic services will have ones. They might have sort of relationships with specific companies where testing is maybe more affordable for that service because of that relationship, and they're able to access further information as well. So different genetic services will use different companies, but a lot of us are overlapping in what we use as well. I think, Heather, we might wrap up.
Yeah, I was just typing about our next Meet the Expert series.
Yeah, I was going to say, next Meet the Expert. So we've got Renee, don't we?
Yes.
From Illumina on the 22nd of September between 8 and 9 p.m.
Yep.
Yeah, perfect. And it's on sequencing machines and genetic testing technology, which will be really interesting and hopefully tie in well with sort of the overarching concepts that we've talked about today.
Okay, thank you everyone for joining us.